Hi, my name's Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. I wanted to take just a minute and show you one of the new gauge patterns that we've added to our portfolio. And this one happens to be a 3-element rectangular rosette. And one of the unique things about it is the size of this planar style rosette. If you look at it closely, you'll see that there are 3 sensitive grids. Each one of these grids are at a 45-degree angle to the other. And this particular strain gauge happens to be a larger size than what we have traditionally produced. I'm going to show you the part number. The part number here says a CEA-06-375UR-350, and all of that means something to us. The CEA means the construction of the strain gauge, and basically that means this one has large copper-coated tabs for soldering. It's made with a flexible cast polyimide backing, so it's very flexible. You can put it on curved surfaces without an issue. And it's also encapsulated, so there's a protective film over the top of it, basically to protect it from me and you while we're trying to get it installed. The next part of that part number says 06, and what that means is what we call the self-temperature compensation for the strain gauge, meaning that it's temperature compensated for materials that expand at 6 parts per million per degree Fahrenheit. Steel would be a very typical example. Some composites expand at that. Some stainless steel alloys expand at that as well. The next part of the part number is the 375UR, and that's what makes this one unique. The 375 is the active gauge length for this strain gauge. So the active area of each one of these grids is 0.375. And the active gauge length really is selected based off the application. I'll give you an example. When you're testing large structures, you're testing sometimes composites, you have a tendency to lean towards a larger size strain gauge so that you can average over a larger area. Some folks want to think that a larger gauge is more sensitive, and that's not really true. What is true is that a larger strain gauge covers more area, averages over a bigger area, and that's really can be advantageous. In particular, if you're on a composite material that's got some coarse fibers in it, you can get some averaging due to the length of these active grids. In addition to that, you'll see after the 375, you'll see the UR. That means that it's the R means it's a rectangular style rosette, which means it's got the grids at 45-degree angles. And then the last part of the part number you'll see is the resistance, and this one happens to be a 350 ohm strain gauge, which is very typical for strain gauges used in stress analysis. If I flip the package over, you'll see all the engineering data that comes with it. You'll see, for example, the resistance and the tight tolerance, which happens to be 0.4%. You'll also see the temperature coefficient of gauge factor, which is basically how sensitive is the gauge factor due to temperature. In this case, it's 1.2% per 100 degrees C. And as we continue to read on down, you'll see that you got a gauge factor for each one of the grids 1, grids 2, and grids 3, along with their respective transverse sensitivity. And then we also provide you a nominal gauge factor, which is sort of like an average of those 3. And when you're looking at these rosettes, the way that they're typically labeled with the tabs facing down, you've got grid 1 to the left, grid 2's in the middle, and grid 3's to the right. Flipping it back over, a few more things you got on this engineering data. You've got, after the gauge factor, you've got the temperature coefficients. This represents the thermal output of the strain gauge when mounted onto 1018 steel. You've got a 4th order equation, the coefficients that you can plug into that equation and show what that data is. You've got a foil lot number, work order number, that's all for documentation. And then finally you get down to the item code. That's a unique identification just for this particular gauge on our system. One package holds 5 pieces, another manufacturing code, and then you got the part number down at the bottom and this 2D barcode. And the great thing about the 2D barcode is that all of the technical information that's found on the package is contained in that 2D barcode. So if you got a barcode reader, you can very, very quickly import all this data into like a spreadsheet, or in some cases into a data acquisition system like ones that we manufacture. But again, I just wanted to take a minute here and introduce you to this gauge. It's a little bit bigger than typical. 375 style planar rosettes, kind of new for us, and you may find that you've got applications where this one would fit. If you'd like to find out more about this strain gauge or any others, feel free to reach out to us. You can contact us through the website, which is www.micro-measurements.com, or you can pick up the phone and call us. Our applications engineers will be happy to answer any questions, and you can reach us at 919-365-3800 and follow the prompts to applications engineering. Thank you.